Assalamualaikum warahmatullahi wabarakatuh and good afternoon to our esteemed and vibrant participants. So we have just had such a fruitful but critical discussion from one para session to the others in the morning. So it's such a nice platform together and witness the discussion from the experts of different organizations, the young and the seasoned professors blending in an event like this. Moving on to the next keynote session, I'm glad to invite Associate Professor Dr. Rohayu Juso to introduce the next speaker. Thank you.
Thank you very much, T.S. Matno, for concluding, for summarizing our morning session. So currently we are moving toward our afternoon session. We will have our third keynote speaker, right? So let me introduce our third keynote speaker for today. Okay, a moment. All right, let me introduce our third keynote speaker for today. So we are very happy to have Madam Fazian Mat Zamberi from Petronas Chemical MTBE. So a brief background about Madam Fazian. She is currently a staff engineer for Oliflex Technology, PCMTBE. Currently focusing on the optimization in current technologies for future benefit. Before this, she is the Operation Engineering Manager, Operation Department, PCMTBE, in which she responsible to manage Operation Engineer for day-to-day plant performance monitoring. And before that, she was the Chief Executive, the Hydro Section, for C4, C3, C4 Oliflex plant and Operation Engineer for C3, C4 Oliflex plant at PCMTBE. Alright, so without further ado, let us welcome Madam Fazian and let us hear the input from our keynote speaker for today. Okay, Madam Fazian, if you're ready, you may start your presentation for today. I think we can't hear you, Madam Fazian.
Sorry again. Okay, you can.
Okay, now okay. Right.
Okay, sorry. Thank you, the chair lady. Can you see my slide presentation?
Yeah, clearly.
Okay. Thank you. Bismillahirrahmanirrahim. Assalamualaikum and very good afternoon, everyone. My name is Fazian binti Mazambri. I'm from Petronas Chemical MTBE Sdn Bhd. Okay, thank you for having me today. Thank you also to organizer for this opportunity because allow me to share my knowledge and also a little bit experience in industry related to this field, catalysis. Okay, touching a little bit about the topic of my presentation. Actually, I've been approached by Dr. Sumaya and Dr. Himardina to talk about catalyst in industry in this session. And then it's actually remind me during my time at university. I didn't get any during that time. I didn't get any opportunity to see the real catalyst and the real equipment, especially in the manufacturing and also in the oil and gas, and even the real story. So, and that makes me shocked during my first early days, my working days. Okay, so today I will talk to you guys about catalyst performance from industry perspective. Thank you again for the organizer cause allow me to use this MS team platform. Okay, we move to outline of the presentation. Okay, first will be my company background and then move to objective for today. And then I've divided my presentation top main topic into two main content, which is first is catalyst and performance, and we have the other subtopic such as heterogeneous catalysis, hydrogenation process, and also performance monitoring of catalyst. And then we'll move to the other second main topic, which is failure mechanism and observation. Okay. And then I will finish my presentation with way forward and prevention. Okay. Um, move to plant overview. Um, I'm from PCMTBE plants and we have two plants here. First MTBE plant and second is PDH plant. MTBE plant operated since 1992 and then the names actually comes from the chemical name methyl tertiary butyl ether. And then we have two licensor which is IFP and also UOP. And then the first of production official for the propylene in 1992 and for the propylene and isobutylene is in 1993. Okay, the next for next for the PDH plant we have actually since 2001 and the licensor is from UOP Oleflex process and first production actually on May 2001. Okay, next is our objective and my objective today actually. This paper presentation will discuss about catalyst used in industry, function and performance monitoring of the yield as a result of catalytic iteration and also ensure maximum production can be achieved in industry. This is actually an industry, the main objective is to get the more production and maximize the production. Okay, we move to main topic. First main topic, catalyst and performance. Okay, this one is introduction. I think most of you in this this is in this session is academician, so we skip number one lah. So kan, basically, we know that catalysis in overall is adding that increasing the rate of chemical reaction and without the catalyst being consumed. So number two, I will focus is common process involving catalyst in industry, which is dehydrogenation and also hydrogenation using heterogeneous catalyst. Actually, we have the idea actually process rather than dehydrogenation and hydrogenation, but in this topic I'll focus on the dehydrogenation and also hydrogenation. Okay, we have the other process such as esterification, isomerization, oxidization. They want also use the catalyst. Okay. Touch about heterogeneous catalysis. This one is catalysis where the phase of catalyst differs from the reactant or product. The process contrasts with homogeneous catalyst, which is when homogeneous catalyst like oxidation of sulfur dioxide, that one is using the same reactor, product, and catalyst in the same phase. Okay.
Sorry to interrupt,
Yeah.
Madam Fazian. I think we couldn't view your slide.
Oh, really?
Mm-mm.
Since when? Yeah.
Just now.
Oh, okay. I shared it again.
Baru saja.
Okay.
Okay.
Is it okay?
Masih tak nampak
Masih tak
sharing.
ada lagi. Ha. Okay.
Oh, okay. 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 So we proceed again to heterogeneous catalysis. I'll focus actually in our industry. We use the different phase of catalyst and reactants. So catalysts that we use in a solid phase, and the reactants and product in whether in liquid or in gas phases. Okay, so dehydrogenation process. Basically, dehydrogenation process is chemical reaction that involve removal of hydrogen, usually from organic molecule, and with presence of catalyst. So this is actually the example of the dehydrogenation process. We also have the in industry. We also have sorry. Can you see my slide?
Yes.
Yes.
We
Okay.
can.
Yes,
Okay. This
ma'am.
one is. Thank you. This one is in good appearance. Okay. We have the other process also. Painting. Dehydrogenation of pentane to pentene. Here I just put an example about the propane dehydrogenation. So propane, when we remove the hydrogen, will produce the propylene, and then propylene will further react with the other like benzene, ammonia, and oxygen, and will produce the polypropylene, propylene oxide, cumene, and so on. Okay. Next, the other process is isobutane dehydrogenation. This one also isobutane go to dehydrogenation process with the technology, various technology actually we have in industry, and then it will become the isobutylene, and isobutylene when react with methanol we produce MTBE, and isobutylene will react with when react with ethanol will produce ETBE and the rest. Okay. Okay, the other process that I will touch is about hydrogenation process. This is an example of the hydrogenation process. It is actually reversible from the dehydrogenation. So we need the hydrogen to produce the other like propylene from methyl acetylene, propydiene. We want to remove one double bond here, and then one double bond here, to produce propylene and also with presence of catalyst. So normally this hydrogenation process, we will use the fixed bed process, and then with presence of catalyst and with control of a liquid space hourly velocity. This one is referred to our feed rate, and then with presence of hydrogen and control temperature. Okay. Okay, we move to since we already talked about the fixed bed reactor, so we move to the fixed bed reactor catalyst. Okay, basically the packed bed reactor is used for catalytic reaction, and the catalyst pellets inside is in place and not move with respect to fixed reference frame and also the lifespan of catalyst. Usually in the fixed bed reactor, we use catalyst that can sustain and can have the lifespan is more than 5 and 10 years. This is for in industry. This is for easy of our change out, and it will schedule with schedule maintenance and schedule turnaround. Okay. Okay. Next to okay, this one is moving catalyst. Besides the fixed bed catalyst, in industry we also have the moving catalyst bed. Okay, usually we have reactor, and then the catalyst will go from one reactor to the other reactor. This is example of 4 reactors. Maybe we in other process maybe we have 2 or 3 reactors depending on the yield that we want to get. Okay, okay, after go through all the reactor, the catalyst will go to the regeneration process to reactive the catalyst and move back to the first reactor for the next reaction. Okay. Okay, performance monitoring catalyst. So we already know a few process and catalysts that been used in industry. As catalysts will accelerate the reaction to produce a product, so we need to monitor the performance of the catalyst. So basically, the three main things that we always monitor is conversion, selectivity, and yield of the catalyst. Conversion, selectivity, and yield is as a result of control process parameter and variable. Conversion, selectivity, and yield are very dependable to our process parameters such as temperature, pressure, velocity of the catalyst, and many more. Sometimes delta P. So that one is actually influence or the influence the reactivity and the performance of the catalyst. Okay, this is the example of the monitoring that we have done, and most industry done is to check the selectivity and conversion. Selectivity yield is actually depends on the conversion and also selectivity. We do monitoring this daily and actually monthly to check our catalyst performance. So as you can see, when the conversion is high, normally the selectivity is slightly low. And then it actually seems like this equation. So when the selectivity is high, the conversion is slightly low. So in industry, to tune at the right condition to get the high and maximum selectivity and conversion is a bit critical, but then we need to do that. Okay. The first main topic, we move to the second main topic, which is the failure mechanism and observation related to catalyst. Okay, this is among the failure in industry related to catalyst. Actually, maybe we have many more, but then I just notified just this failure, this type of failure. First is catalyst deactivation. Second is catalyst deteriorate prior lifespan warranty. The third one is catalyst chunk or agglomerate, and then catalyst loss of containment. Um, Basically, the cause of failure is first due to the catalyst deteriorate due to manufacturing. This one, mm, actually, for the first cases, for the first case, we must have detailed design review of the catalyst that we want to purchase with manufacturer, and also we need to have the agreement on the performance warranty prior we buy the catalyst. And then sometime in industry we do the bucket test for catalyst. We um, we put the catalyst in the bucket and store in our process within a duration that require, and then we see the performance first, and then after that we'll decide whether we want to buy or not the catalyst, depending on the performance of the catalyst. That one is a part of selection of the catalyst, and also absorbent actually. Okay. um Number two, uncontrolled process parameter. This one is also common to the process when we not control the temperature, the pressure. So sometimes catalyst will damage and will cause failure, and eventually will shut down the plant. And then the third one also famous in industry, which is the mechanical failure. Mechanical failure will involve actually integrity of the equipment, and how it's related actually with how we do the preventive maintenance at plants, the strategy of the preventive maintenance. Okay. Uh, we move to failure observation. Okay, this is example of excessive damage with some leakage catalyst due to improper regeneration. Okay, this one maybe this one basically due to high fluctuation of temperature at the regeneration bed, and um, eventually it will produce the fines generation catalyst fines, catalyst fine, and then it will block the mesh or clog the screen. Next, failure observation involving cooling water pipe. As you can see, this one, okay, as you can see, this one we have catalyst at the surface of piping, point of leak and crack, water observed just after catalyst unloading completed. So that means during the process, catalyst is not moved due to the water inside, and the catalyst become agglomerate. Okay. For this one also, um, sorry, moisture and free water is no to certain catalysts, because this is a solid catalyst application. So thus to ensure there is no free water inside the catalyst bed, usually we need to check the dew point reading as to ensure no free water and no higher moisture inside the catalyst bed prior put online the catalyst bed after overhaul or any repair work. Okay, this one is a failure mechanism involving the equipment. As we can see here, baffle, stiffener, corrosion, thinning, and deformation. This one is, we can see high horizontal crack observed as a result of high temperature during operation. Okay, we move to next failure observation. This one, when we have a screen or mesh inside our catalyst bed, if we not control the temperature, and then the temperature maybe fluctuate too high, or maybe the temperature actually too high, so it will become buckling and erosion at the internal catalyst bed. Okay, at the sense, as you can see the moving catalyst just now, to reactive the catalyst, we need to inject the chemical such as chlorine, such as so many things, the others. And then sometime uh, when the oxidation process happen, we will spot a greenish corrosion, and sometimes it unable to clean all trap or residue catalyst at the mesh and screen. Okay, next failure observation. This one is at the nozzle. Evidence of catalyst found clogged at the entire surface of the vessel outlet nozzle. Moisture appeared in the process, suspected cause of failure. So this one is like I said just now. So after we remove all the water, after all the maintenance, we need to check back all the moisture reading inside using the portable dew point meter to ensure there is no moisture inside. Okay, this one is pinhole leak. Pinhole leak was found in one of the tubes inside the catalyst bed. Actually, the cooling water in industry, sometimes we will use cooling water to reduce the temperature of the catalyst. So then actually the preventive maintenance need to do to the piping of the cooling water, and also cooling water quality need to check always as to ensure that there is no clog of water inside the piping. Okay. So, okay, next is radiography test. This is the type of NDT that in industry use. It is conducted to assess integrity of equipment and piping. Pictures, okay, showed evidence of lack of root penetration, and actually this one showing that rejectable condition. Okay. Every failure had impacted significantly to plant operation and loss. This is actually the impact to the industry that we don't want actually. So one of the impact is a loss of production. Loss of production, we require to shut down 10 or 10 to 12 days, or is if it related to the catalyst, and then it was reduce our production. And then loss of catalyst, this one is also incurred cost because we need to buy the new catalyst. High catalyst consumption and top up due to high fine generation, high catalyst, small catalyst that actually is not okay to the reaction. So, and then the last one is the impact is a high repair cost. Um, to prevent all the recurrence and all the failure, we need to have the action. So this is actually among the action that industry takes as to ensure the failure is not happen, or failure did not happen and again and again and recurring. So first is basically closely monitor our process parameter. That one is the most important, such as pressure, temperature, flow, and flow. And then move to temperature monitoring of piping, equipment, and also equipment enhancement. This one actually is relates to the piping burst just now. So maybe we need to have that enhanced temperature monitoring. Okay, and then explore early detection of moisture presence inside catalyst bed. This one actually part of troubleshooting. If happen to be moisture is inside, but we need to have the measurement and the monitoring at the catalyst part as to ensure all the symptoms we tackled earlier. Okay. And then detail inspection during overhaul and equipment shutdown. Basically, we will do it during the scheduled maintenance and also scheduled turnaround. And also, the last part is, but important part also is the preventive maintenance that we must do to ensure all the equipment is in good condition. Okay, that's all my slide presentation. Thank you.
Okay, thank you very much, Madam Fazian, for the very interesting input today. So let us proceed with question and answer session. So any question from the floor?
Okay, I have one question, Ms. Fazian. Such a really wonderful presentation, practical. May I know what is the tolerance of moisture? That I know your catalyst is very sensitive at. So what would be the range of, I think, ppm level so that it's acceptable? Yeah.
Usually we do monitor the moisture. We want to get less than 1 ppm.
Oh, that's very stringent. Okay, okay, I
Yeah,
see.
that's very stringent.
Very, very, yeah. Okay, thank you very much for the answer.
Okay, welcome.
Okay, thank you very much. We are very sorry that we just can have one question from the floor because we're going to go to other parallel session after this. So
Okay.
thank you very much. I think if you have any other question, you can email maybe, Madam Fazian.
Yeah, of
Okay.
course. Yeah,
Maybe we
sure.
can share your email to the participant if they have something to ask maybe.
Yeah.
Right? So
Okay.
thank you very much, Madam Fazian, and also our participant today. So maybe after this, we can proceed to the parallel session. I pass back to TS Matno.
Thank
Yes,
you
thank you very
again.
much. Yeah, thank you very much again to Mrs. Fazian. Actually, we are very happy to have you with us. It's really, really making this RECaSE more meaningful. All right, so I would like to invite everyone to join our next parallel session 2, which gonna start right after this. Okay, so yeah, it's time now to go to your WhatsApp group and click the right track that which you are interested in. Okay, so thank you very much and see you guys in this afternoon. Bye bye.
Thank you, Miss Fazian.
Thank you, Mrs. Fazian.
Thank you, Mrs. Fazian.
You're welcome. Thank you again for this
Yeah, very
opportunity.
interesting.
Okay, thanks.